Imagine tackling an incredibly complex project, say, developing a new piece of software or writing a detailed research paper. Now, instead of struggling alone pulling all-nighters, you suddenly have this elite team of specialized AI experts. Each one knows exactly their role, how to contribute, and they work together, seamlessly to get it done. That's the powerful promise of multi-agent systems, where AI doesn't just work, but collaborates.
Precisely. And today we're taking a deep dive into Agent Group Chat V2. This isn't just another incremental update. It's a groundbreaking framework. It systematically addresses critical limitations in how AI agents work together. We're going to walk through this material, much like an academic paper, actually, from its core ideas and innovative architecture right through to its impressive experimental results. The aim is to give you a truly comprehensive understanding of what makes it so significant.
Okay, so our mission today is to uncover the why and the how behind Agent Group Chat V2's success. We're extracting the crucial insights and, well, some surprising findings directly from the research. By the end of this deep dive, you'll be in a really clear picture of how this new paradigm is shaping the future of AI collaboration. So how are we structuring this? We'll start by setting the stage, covering the foundational concepts and the challenges in multi-agent systems. Then we'll unravel Agent Group Chat V2's truly innovative architecture. After that, we'll dive into the experimental data, looking at where it truly shines and, importantly, where it reveals its current limitations. Finally, we'll wrap up with a look at some pretty compelling real-world applications. Okay, let's unpack this. We often hear multi-agent systems. What exactly does that mean? And what makes LLM-based multi-agent systems unique?
Right. So at its core, a multi-agent system, or MAS, is basically a network of autonomous agents. They interact with each other to achieve collective goals. Think of it as distributed intelligence working together. It leads to enhanced reasoning and problem-solving capabilities. Now, when we specify LLM-based, it means that each individual agent uses a large language model and LLM as its brain. This gives them remarkably human-like interaction capabilities and allows for highly sophisticated decision-making within the system.
Okay, so with that kind of sophistication, where are these systems showing the most significant potential? Where are they truly beginning to, make a real splash?
Well, the research highlights two primary application domains. First, there's social simulation. This involves modeling human-like social interactions and behavioral patterns. Imagine simulating, say, opinion evolution within a community, or analyzing market competition dynamics, or even understanding how rumors spread and how you might manage that. It's really about gaining insights into complex social phenomena.
Interesting. And the second area?
The second area is complex task resolution. Here, LLM-based multi-agent systems enhance reasoning, planning, and creative problem-solving. Think about incredibly challenging fields like software development or legal argumentation or even tackling advanced mathematical problems. They really leverage that distributed intelligence to break down and solve problems that would simply, well, overwhelm a single entity.
That sounds incredibly powerful, but I guess it's rarely all smooth sailing, is it? What were the big hurdles that existing multi-agent frameworks faced, the ones Agent Group Chat V2 specifically aims to overcome?
That's right. There have been some significant systemic challenges. First, the system architecture challenge. Many existing designs just aren't built for large-scale, resource-intensive collaboration. They often rely on sequential execution.
Right, one after the other.
Exactly, which is fundamentally inefficient for complex, interwoven tasks. Second, there's the generalizability challenge. Most current designs are highly customized for very specific scenarios. They lack the adaptability to work effectively across different domains. It makes it really difficult to create a truly universal system.
Yeah, that makes sense. If it only works for one specific thing.
Precisely. And finally, perhaps the most frustrating, is the performance guarantee challenge. Sometimes, despite their complexity and the promise of collective intelligence, these multi-agent systems actually perform worse than simpler single-agent approaches. They don't always demonstrate a clear, consistent advantage, which has been a major roadblock to wider adoption.
So those are the big hurdles. How did Agent Group Chat V2 propose to tackle such fundamental issues? Was there a core strategy that made the difference?
Absolutely. The bedrock solution proposed by Agent Group Chat V2 is deeply rooted in the classic divide-and-conquer principle. Now, this isn't just about breaking down tasks, although that's certainly part of it, what we call task decomposition. But crucially, it also involves optimizing the organization of agents by specializing them for specific subtasks. This approach inherently enhances parallel execution and, most importantly, significantly improves overall collaboration and problem-solving performance. It's quite elegant, really.
That divide and conquer philosophy sounds powerful. What specific innovations did Agent Group Chat V2 introduce to actually put that into practice?
Okay, yeah, this is where it gets really interesting. Agent Group Chat V2 brings three core innovations to the table. First, a divide and conquer fully parallel architecture. This allows it to break down complex queries into what they call hierarchical task force structures. It's like imagining not just a single project plan, but an entire interconnected ecosystem of sub-projects.
Wow, okay. A forest of tasks. It's exactly. This enables dependency management and distributed concurrent processing across the whole system. Second, an adaptive collaboration engine. This dynamically selects the right combination of heterogeneous LLMs, meaning different types of LLMs, maybe one's better at code, another at reasoning, and it adjusts their interaction modes based on the specific task. It's about assigning unique identities or roles to these LLMs on the fly.
Adaptive, got it. And the third.
And the third innovation is agent organization optimization strategies. This takes that divide and conquer principle and applies it deeply at the execution level. It does this by strategically assigning specialized roles to each agent. It's not just dividing the task, but dividing the labor intelligently.
That's fascinating. So digging a bit deeper then, how is this all put together? Can you explain the actual nuts and bolts of its tripartite architecture? You mentioned that's key to its functionality. Absolutely. At its heart are three core components, working together like a well-oiled machine. First, you've got the query manager, which is LLM-powered. This acts as your intelligent assistant right at the front end. It takes your complex user query, uses its LLM brain to understand the meaning, and then breaks it down into a clear task tree structure. Then, once all the subtasks are completed down the line, it integrates and formats the results before sending them back to you.
So that's the smart front end. What's the central brain, the coordinator?
That would be the task manager, which is CPU-powered, interestingly. Think of this as the central air traffic controller for the whole operation. It maintains the state and execution of the entire task forest. Remember, that can be multiple interconnected task trees. It meticulously tracks all the parent-child relationships between tasks, manages the flow of information, and efficiently distributes independent tasks to the group managers for parallel processing. And it does all this based on the system's current load, trying to keep everything balanced.
Okay, so query manager takes the request, task manager directs the traffic. What about the group manager?
All right, finally, we have the group manager, also LLM-powered. This is the execution component where the work actually gets done. Its job is to set up and coordinate these multi-agent group chats for specific tasks. This includes selecting the precise LLMs for the agents involved, allocating a scratch workspace. Think of it as internal memory or thought space for the LLM, and object resources, which define their specific roles for, like, human oversight. And crucially, multiple instances of the group manager can run in parallel. That's what gives it real scalability and concurrency.
That paints a really clear picture of the architecture. Now, what does this all mean for the actual group chat itself? How do these specialized AI agents truly interact and manage their tasks within this system?
Good question. So the basic unit of work here is the task. It's essentially a defined problem with a clear goal, and it moves through a life cycle. Initialization, waiting, execution, completion, or maybe failure. A group is the collaborative work unit where the task gets tackled. It brings together the assigned agents and the necessary resources. And each agent is like a unique team member. It has its own agent ID, its own LLM brain, maybe Claude 3, maybe Qwen 3. It also has that scratch space we mentioned for its internal thought process and maintaining its assigned identity or role. Plus, it has object information, which describes its specific role, making its function transparent to you, the user. And of course, it keeps a history of its conversation records.
So Scratch is for the AI's internal stuff. Object is for human understanding of its role. Makes sense.
Exactly. And the group manager orchestrates this whole iterative process. Agents perceive their environment, the current state of the task, messages from others, decide on actions, execute those interactions, like sending a message, and then update their environment based on the results. The system supports both broadcast messages, sending something to everyone in the group, and directed communication for more focused two-agent dialogues. This allows for incredibly flexible interaction patterns depending on what the task needs. Dialogue summaries are generated along the way, and task completion is continuously checked, ensuring the group stays on track.
Okay, that's the setup. Now for the results. You mentioned rigorous testing.
Yes, absolutely. Let's talk about the proof in the pudding, the experimental results. Agent Group Chat V2 was rigorously tested against various baselines, standard approaches like naive, naive code, react, autogen, and multi-agent debate. They used powerful LLMs like Qwen 2.572b and Llama 3.170b and tested it across diverse domains to really see how it held up.
So after all that rigorous testing, what stood out in its overall performance? Where did it really shine?
A lot stood out, actually. In mathematical reasoning, it showed truly superior performance. Especially on high-complexity problems like A, it achieved 30.4% accuracy, which is nearly double the performance of the baseline methods.
The double.
Yeah. And on level 5 math problems, it saw over 11 percentage points improvement compared to the best baseline. The secret, as you might guess, was that effective task decomposition and agent specialization. It reveals a crucial principle. For truly hard problems, specialized AI collaboration isn't just a little better. It can be transformative. It breaks through bottlenecks single agents just can't get past.
That's a significant leap. What about something different like code generation? How did it fare there?
For code generation, it was excellent at generating initial solutions. For example, it hit 79.2% pass at 1 on the HumanEval benchmark. The collaborative analysis seems to rapidly produce strong first solutions. But interestingly, and this is quite nuanced, it might actually limit the exploration for diverse solutions at higher sampling rates, like asking for multiple different answers.
Huh. So it's good at finding a good answer quickly, but maybe not as good at brainstorming lots of different potential answers.
That seems to be the case. It suggests a fascinating trade-off. AgentGroupChat-V2 excels at converging on a strong initial answer, but it might sacrifice some of the broad, divergent thinking needed for truly novel or varied solutions. That's a common challenge in creative problem solving, of course.
That is an interesting trade-off. Okay, what about common sense reasoning? You'd think more agents would help there.
Well, here's where it gets even more interesting and perhaps counterintuitive. AgentGroupChat-V2 sometimes performed worse than simpler methods on common sense reasoning tasks.
Worse? Really? Why?
It seems its task decomposition and multi-agent coordination actually introduced unnecessary overhead for straightforward questions. When an answer is pretty obvious, breaking it down and having multiple agents deliberate can lead to what they call over-deliberation. An initial correct interpretation might even get questioned and overturned through too much discussion. The key insight here is that sometimes, more agents and more complexity isn't always the answer, especially for simpler tasks.
Right. Don't use a sledgehammer to crack a nut kind of thing.
Exactly. On the other hand, in structural text understanding, like understanding complex documents, it showed impressive robustness and performance stability as the context complexity increased. This demonstrates that its divide and conquer strategy effectively manages what's sometimes called context explosion, that problem where an AI gets overwhelmed by too much information. It handles it very well. And for domain-specific knowledge, it exhibited adaptive effectiveness. It excelled in tasks requiring multi-perspective analysis, like financial reasoning, and maintained competitive performance across other fields, like legal and medical domains.
That's a very nuanced picture of performance across different areas. It really makes me wonder why these specific differences. Did the ablation study shed more light on how the agent organization impacts things?
Absolutely. The ablation study, which they conducted on 100 level 5 math problems, revealed some crucial insights about the number of agents and, importantly, their roles. When agents had specialized roles, performance improved significantly as you add more agents. For example, going from just 2 agents up to 5 agents saw accuracy jump from 32.5% right up to 53.5%.
That's a huge jump.
It is. It clearly showed that having more specialized agents leads to more effective collaboration and avoids redundancy. The system could effectively coordinate these larger teams when roles were clear.
But what happened if the agents weren't specialized, if they all had general roles?
That's the key contrast. When agents had general roles, meaning they were all basically doing the same kind of thing, performance actually deteriorated as more agents were added. It went from 34.5% down to 31.5%. The insight here is pretty clear. When everyone has the same generic role, adding more agents just leads to more repetitive information, less focused discussion, and ultimately hinders progress. And interestingly, traditional frameworks they tested, like AutoGen and multi-agent debate, also showed performance declines as agents increased, suggesting they also struggle with managing large-scale, undifferentiated interactions effectively.
That really highlights the importance of specialization. What about the impact of dialogue rounds? How many times the agents talk back and forth? Does more conversation always lead to better outcomes?
Not necessarily. For specialized roles, the system required a moderate interaction depth for optimal performance. There was an initial increase in accuracy as the dialogue deepened, but then it slightly decreased after a certain point. This suggests that enough dialogue is needed to integrate the specialized insights. but too much can become overly complex or lead to diminishing returns, maybe confusion.
Finding the sweet spot.
Exactly.
Mm.
For general roles, however, performance was relatively insensitive to the number of dialogue rounds. Extended dialogue mostly just produced repetitive information without leading to new insights. It really reinforces the idea that just talking more isn't helpful if there isn't clear specialization or purpose behind the interaction.
Okay, so taking all these findings, the overall performance, the ablation studies, what does this mean for real-world application? The paper gives some case studies, right, showing how this divide and conquer plays out practically.
Indeed. They provide some compelling examples. The first one is interactive data visualization tool development. Now, this is a complex task, right? It gets broken down hierarchically. Think about the different pieces. Designing the module interfaces, handling data processing in parallel, developing the actual visualization components, and then doing unified testing. Each step uses specialized agents. For instance, you might have a requirement analyst agent, a code implementation agent, a code review agent, and a test planning agent. They all work on their specific parts of the project, often in parallel, leading to what should be a much faster, more robust development cycle.
It's not just for software development, right? They also looked at blockchain technology analysis article writing. That's a completely different kind of task.
It is, and it's another great example of how parallel decomposition works here. It starts with parallel research tasks. Maybe one agent does a technology survey, another collects relevant case studies, a third does market analysis, then it moves to parallel chapter writing for different sections of the article. Finally, there's an overall optimization and refinement stage. Again, each phase is handled by specialized agents designed for that specific type of work, really demonstrating the framework's adaptability across domains.
And for a really concrete example, like seeing the agent dialogue in action, they detail the file parsing task. How did that show the system's collaborative refinement?
Yeah, this case study gives you a clear window into how those iterative, specialized interactions work. You can imagine a requirement analyst agent refining the specifications for the parser. Then a code implementation agent iteratively develops the code based on that feedback. And alongside, or maybe after, a code review agent provides multi-perspective quality checks, pointing out potential bugs or suggesting improvements. You can actually see the back and forth in the paper's examples, how they build on each other's contributions to systematically improve the solution, identifying errors and optimizing the code in this truly collaborative loop. It's quite fascinating to see play out. So if we try and connect all this to the bigger picture, what AgentGroupChat-V2 offers is, well, a genuinely comprehensive solution for building these LLM-based multi-agent systems. Its key innovations that divide and conquer parallel architecture, the adaptive collaboration engine, and those optimized specialized agent roles, they systematically address the core challenges the field has been facing.
Yeah, it's really fascinating to see how it achieves that superior performance, especially on complex reasoning tasks like math and code generation and structural text understanding, and crucially, how it maintains generalizability across different domains. It seems the advantages really become more pronounced on the harder tasks where you truly need that collective AI intelligence to solve problems that would just, well, overwhelm a single agent.
Absolutely. I think this really establishes a new paradigm, or at least points towards one, for practical, high-performance multi-agent systems going forward.
So, what does this all mean for you listening? As these specialized AI teams become more sophisticated, more capable, imagine how they might reshape industries. You could see accelerated scientific discovery, streamlined complex business processes, maybe even highly capable personal AI assistants that can tackle multifaceted projects for you. The potential feels pretty vast.
It really does, and it raises an important, perhaps even profound question to think about. What kind of entirely new problems might we be able to tackle when we can assemble these highly specialized collaborative AI teams almost at will? And maybe even more fundamentally, how might that change the very nature of human-AI collaboration itself? Definitely something to mull over until our next deep dive.